All right, hi you guys. Today we're going to be working on evaluating expressions. You should have a notes sheet in front of you to fill in the blanks with and then to use as the place where you're going to take notes today as you watch the video. So when you're done with those notes for today, you're going to glue everything into your Min, but you're going to need to have it in front of you as you're watching and complete as you go. So evaluating expressions. When we evaluate an expression, what that means is that we are substituting, literally swapping out a variable for a number. And when we evaluate expressions, we need to use substitution before we even begin. So substituting literally means rewriting the numbers in place of the variables as we go. And I'll guide you through this so you understand exactly what my expectations are. All right, we have a few examples here and we'll just go through them together. So we are going to evaluate each expression if A equals 5 and B equals 2. This oftentimes is a very easy thing to do. It feels like mental math, but it's really important that we take the time to use that substitution step and rewrite the problem with numbers all in place of the variable. So when I see an expression like A plus B, and I know that A has a value of 5 and B has a value of 2, I just write in my new numerical expression 5 plus 2, and then using my order of operations, I simplify. On the second example, when I see 3A plus B, I know that means 3 times A plus B. So again, my very first step is using substitution, showing that I'm multiplying 3 times 5, adding on 2. So after I rewrite it, then I'm going to use order of operations to go through and simplify one step at a time to get a value of 17. You should be doing this alongside with me on your sheet. On the third example, we know that A equals 5. So we're going to substitute 5 plus 4 times 2. Remember that 4B means 4 times 2. On the next line, even if it's easy mental math, I want to show you I want you to show that we're doing literally just one step at a time. 5 plus 8 to get a value of 13. We're using our steps for order of operations, so remember, no equal signs, carrots, Doritos, all those things that we have talked about in the past. All right, make sure that your notes are complete, that you have all the same steps that I do before we go on. If you need to pause, go ahead and pause the video. All right, we're going to step it up a little bit. We'll get a little bit trickier in the next set of problems. So this time we're going to evaluate expressions where those variables stand for fraction values. So we've got x equals 1/2 and y equals 3/4. Remember that first step involves just using substitution. So I'm just going to rewrite the problem using numbers 1/2 plus 3/4. We should know, and hopefully we do, that I can't add halves and fourths unless I have my common denominator. So I need to take the extra time to figure out, well, when I add halves and fourths, what's my common denominator? I see that I have 4 as a common denominator. 1/2 becomes 2/4 plus 3/4. Notice that I'm going to keep working my way down to get an answer of 5/4, and 5/4 simplifies to 1 and 1/4. So these might take us a few extra steps to get through, but that's okay. For x minus y, we're going to fill in 1/2 minus 3/4. We already know that 1/2 is equivalent to 2/4 minus 3/4. This is a really good situation for definition of subtraction. We're going to keep change this because we're taking away a bigger number. And we end up with 2 plus -3, which is -1. And denominator stays the same, so we have an answer of -1/4. When I see x, y next to each other, we know that that means I'm going to be multiplying. So I'm going to multiply 1/2 times 3/4. I'm looking across. Is there anything that I can do reducing with? I see there's nothing here. 2 and 3 don't reduce to anything. 1 and 4 don't reduce. So I'm just going to multiply across. 1 times 3 gives me a value of 3. 2 times 4 gives me a value of 8. So my answer is 3/8. And for the last one, we've got x divided by y, which most commonly we'll use the fraction bar to show. So that's sort of a weird thing to have a fraction within a fraction. So whenever I have fractions that I'm going to be dividing, I just find it easier to rewrite the problem as 1/2 divided by 3/4. Remember that when we divide fractions, we are really multiplying by the reciprocal. So we're going to change division into multiplication. We're going to change that 3/4 into its reciprocal. So our new problem turns into 1/2 times 4/3. And as I look across here, I see that the 2 and the 4 can be reduced by 2 to get 1 and 2. And now I'm ready to multiply across. 1 times 2 is 2. 1 times 3 is 3. All right, so not too much more difficult, but now we've got some fractions to evaluate with our expressions. Okay, take your time on these kinds of problems and just check your work carefully. All right, and we're going to finish this today with looking at expressions that now contain negatives. Again, we're going to follow those same steps. So when we see evaluate, we know we're going to substitute in and rewrite the problem. So 2x minus 3 becomes 2 times negative 2 minus 3. I see a lot of negatives here, so I'm expecting that I'm going to have to use a little keep, change. Negative 4 minus 3 turns into negative 4 plus negative 3, and now we're ready to simplify that down to negative 7. In the next example, we've got xy plus 4. We know that means x times y, so I've got negative 2 times 3, and I'm going to add 4. Negative 2 times 3 is negative 6, plus 4 to give me a value of negative 2. And the last problem is 10 minus z. So look at this. I've got 10 minus negative 4. We know that that's a keep, change situation. 10 plus positive 4 gives us a value of 14. Okay? That's basically how we evaluate expressions. You guys, for the next part of the class, you've got 4 sample problems to try all on your own. I want you to work alone on these, and then you may go ahead and check them with a partner, and then I will have some more work for you to complete once you are done. Okay, thanks, guys.